That is essentially what has become Rendered AI, is recognizing that there's a fundamental breakdown in how we're designing and building our next generation systems. And it comes from this paradigm breaking need to have data before you've launched a product in order to design the product. And then really thinking hard about what does it take to engineer that as a solution. Not just how do you produce imagery, but then how do you iterate on that? How do you have how do you build quality control, reproducibility, and auditability into that? And so that's what's become Rendered.
Hey, everyone, and thanks for listening to another episode of DIB Innovators. Today, I'm speaking with Nathan Kundtz, CEO and co-founder at Rendered.ai. Nathan, thanks so much for joining.
It's my pleasure. It's great to be here.
Yeah, that's great. Well, a lot to unpack here in the space of AI, but tell us a little bit, the journey that, you were in education or academia, and then how you found yourself as a co-founder of Rendered.ai.
Yeah, so I did my PhD work in physics at Duke University, actually, in a field called metamaterials. And so about 10, 15 years ago, there was a lot of excitement about the metamaterial cloak and some other really wild new devices coming out. And I was the first one to sort of measure some of the efficacy of those devices and start to think about what applications could be produced.
What is metamaterial?
Oh, yeah, excuse me. So just to be clear, this is more my background than relevant for Rendered AI, but a metamaterial...
No, but it's good. I think it's important.
Materials in which we sort of, you can think about them as materials in which we can design individual atoms and all of the things that start to happen once you can design at that level. Now, a lot of what we did was at microwave frequencies, so that the atoms could be macroscopic, but nonetheless, you can get some really wild behavior. In fact, what we were doing was aligning some design principles that came from general relativity, where we could sort of warp space, and then we could implement that warping in a material, which is essentially how the cloak works. So that's what I did my PhD work on, both the theory and experimentation around those things. And there was a group out in Seattle led by Nathan Myhrvold, the former chief technology officer of Microsoft, that was buying up the intellectual property from that. And he asked me to come out and help them figure out how to commercialize those inventions. So I did that, and actually that became one of 6 different companies that have spun off of intellectual ventures on the back of metamaterials. But I was the CTO and then CEO of a company called Kymeta, which was using those metamaterials design concepts to produce electronically scanned antennas for satellite communications. So when we think about like Starlink or OneWeb, you need to track, for instance, satellites that go across the sky. And so Kymeta was one of the first companies, really the first company, to produce a commercially viable flat panel antenna with no moving parts. And we did that using liquid crystal display production. And Kymeta to this day is sort of the standard solution for OneWeb. So that was an exciting first job. I left Kymeta in 2018. It just became time for the company to be run by a growth management team. And being a physicist, it was time for me to get back to doing something that was near and dear to my heart, essentially technology development. And in doing that, I started working with a lot of small companies, with the idea being not that I knew a great deal after my experience N equals 1 of building a company, but I knew enough to maybe help them avoid some scar tissue that they didn't have to achieve for themselves. And so I was working with groups like Creative Destruction Labs out of Toronto and others in the Bay Area, and started to hear a really consistent theme in companies that were up and coming in the satellite industry. And it would go something like this. And if you're in the industry, this will probably sound very familiar. Some academic institution or national lab group has come up with some really cool sensing technology, and maybe radar or hyperspectral or thermal or something. And they want to put it on a satellite and send it up into space. And if you sit down and you talk to them about what that looks like as a business, they say, well, we can do really cool stuff, right? We can see through clouds. We can detect methane plumes. We can see algae blooms. Like, we can all sorts of great stuff that's going to be really important for the human race. And you say, that's awesome. How do you make money? Because if we want to make this a business, that's important. And they say, well, the reality is most of the customers won't be able to actually use our data directly. They're going to have to we'll have to sell them insights. So we'll have to actually analyze the data and essentially provide an information product as opposed to a data product. You go, that makes sense, right? Of course, like most people don't know what to do with hyperspectral imagery. They don't have a PhD in that. They really don't know how to analyze it. But then you have to ask the question, so how are you going to do that? Because those are a lot of different applications, a lot of different information products. You say, well, we're going to use artificial intelligence. And you go, yeah, of course you are. Everybody. That sounds awesome. Let's use artificial intelligence. Great. Like, let's rub it in. It sounds good. Do we get that at the supermarket? Like, how do we do that? And they say, well, it's a new type of sensor. And you go, yeah. And they say, to produce AI, we have to have data to actually produce the AI. And you go, yeah, so that's a problem, isn't it? Because like your satellites like literally don't exist yet, let alone haven't launched. Like that doesn't exist. So how are you going to do that? And they go, well, we're going to raise $200 million. We're going to build our satellites. We're going to launch them into space. We're going to manage them for 6 months to 2 years collecting data. We're going to pull that data down. We're going to use scale AI to label it. And then we're going to build our algorithms and we're going to figure out whether we can help anybody. And you go, really? Huh. Like, that sounds great, guys. Awesome. Really, really challenging business model, right? So that, and I saw that happen over and over again. And there were two important thoughts that came out of that. One was, these are actually real problems. Like we have things that we could be doing to meaningfully improve the state of humanity, so to speak broadly. Like these are things that could really help. And so in some sense, like it should exist. We want this to exist. It's not that they're proposing something that has no meaning, but it doesn't fit within the model-based design kind of engineering paradigm that we're used to working against. And frankly, that is the basis for our ability to fund technologies. And then the next thought is, well, maybe these are just a bunch of quacks from universities that just don't understand that. And, it's because I'm sitting here in the backwater of the satellite industry where that's who we work with for some reason. So I dove into the latter question, right? Like, is it really that? Are there other answers that people are using? And as I went into robotics and healthcare and manufacturing and insurance, it was always the same story. You ask, Tesla, how are you going to handle your next generation cameras? They're like, we're going to build a bunch of them and we're going to have to drive, 30 million miles before we're able to integrate that into our AI pipelines. You're like, wow, that sounds incredibly expensive. Like, how do you even make that engineering tool? Healthcare, golly, they don't even know how to get it, right? Like, how do you design a next generation X-ray system when it's not going to be a human radiologist that's analyzing the output? Nobody knows. And this struck me as just a really kind of profound, broken link in how we were going to do engineering broadly going forward. And it was this problem that you in the past, we've always been able to make really solid guesses about how our devices would perform before we built them. Right. And all of engineering is predicated upon that. And then suddenly we can't do that. So then being a physicist, I said, maybe we could simulate this data. Like, what? Surely, this has been done. And it turns out, yes, this has been done. This is a field called synthetic data. I was like, well, that must be really, really important. Let's get into not just saying we can simulate it, but what do we have to do to simulate it accurately? Like, how do we actually turn that from something where we just, grab a simulator or a video game engine to produce imagery and start turning that into an engineering workflow? And I hope you'll forgive me for the long-winded answer, but
this is fantastic.
That is essentially what has become Rendered.ai, is recognizing that there's a fundamental breakdown in how we're designing and building our next generation systems. And it comes from this paradigm breaking need to have data before you've launched a product in order to design the product. And then really thinking hard about what does it take to engineer that as a solution. Not just how do you produce imagery, but then how do you iterate on that? How do you build quality control, reproducibility, and auditability into that? And so that's what's become Rendered.
Yeah, that's fascinating. Well, because AI obviously is the big, buzzword nowadays, as people chuckled about it, and it is just kind of plastered all over everything. You put AI in your title and your website, now all of a sudden you're an AI company. But as you look at these problems. Can you talk to me about the different types of AI and how synthetic AI is really thought about and engineered or worked through to really bring that value?
Yeah, absolutely. And yeah, maybe a couple points there. Yeah, every company is an AI company these days, in the same way that every company is a software company. Like you can't, if you're, including, I'm sure your podcast is using like a significant amount of AI in processing the output and preparing it, and you're using it in a whole variety of different tools. And so we are all AI companies. But what really distinguishes AI from other types of software is that the behavior of the AI systems are based on data instead of being based on code. And so when we start to distinguish different types of AI systems, we need to not only distinguish sort of the algorithmic piece, but also where did the data come from? So there's all sorts of things happening right now in generative AI. Large language models, I think, are incredibly important. We're starting to incorporate those into our own workflows so that we can start to automate some of these processes. But another type another way to use generative AI is to produce actual imagery. So you can actually task AI systems like Midjourney with the production of imagery or video. And that is distinct from what we're doing when we produce data. And so this is a distinction that I think is maybe helpful to make here. There are generative AI tools in which you can provide a prompt or maybe an example image and then get other imagery out. But the problem with that is you don't have sort of provability about what's in that image. And if you use those images to train another AI system, you tend to find that those systems collapse. They don't continue to learn, essentially because you're not producing any new information. So what we need to do with Rendered is we need to produce something that's actually novel to the system, like imagery that has new information that wasn't otherwise in an AI tool. And in order to do that, we use physics-based simulation. And so that's an important distinction, and maybe gets into a little bit of your question about the different types. We think about different types of data generation. So there's physics-based synthetic data generation, and there's generative data generation. Like everything in the world, it's not that crisp. You have varietals within those two. But what we really emphasize in our tools is physics-based data generation, which allows us to introduce new knowledge, calculate things that are truly novel, and create information essentially that wasn't already in the AI model.
So do you find, for specific use cases, is there really any place where, if I use your kind of context of, I've got to get data to train a model so that I can efficiently look at data that's going to change over time, but now I have that.
Yeah.
So does that apply to any application, or is your generative AI trying to look at like a sensor and knowing what a sensor can do? Now we write the code to be able to pull that in, or are you helping designing the sensor based on, I know the data that I need to look at to answer the fundamental questions. Now we can, knowing physics can make sensors, or does this apply across not just like physical hardware, but across, any type of data collector, if you will?
Yeah. Wow. That is a multi-part question. There's a bunch to unpack. Let me take a minute. So let me start with maybe the most concrete answer, which is just sort of how does our platform work? We work with the best simulation providers in the world to bring like really amazing simulation technology forward on our platform that tends to be then somewhat specific to sort of the domain that you're operating in. For instance, we don't use Unreal Engine when we're trying to do synthetic aperture radar simulation. We use synthetic aperture radar simulators. We use radar simulators. And we have hyperspectral simulators and X-ray simulators and things. And because we have that level of fidelity, that allows us to typically twin the sensor of interest fairly accurately. Does that make sense? We're not trying to represent it as just what you would get out of a video game. We're like, no. This is a push-broom hyperspectral sensor. It is not an RGB, CCD array. Those would be modeled differently. And because of that, one of the questions that you asked is sort of, are you trying to define the hardware, or are you trying to answer just represent it? And we do both, because you can then parameterize those things, and you can start to ask questions like, should I add spectral bands or should I add spatial resolution? Right? It's like a natural question if you're building a hyperspectral sensor. And then the thing that you want to know is not just what would a human see, or how could I analyze it? But how will that affect my automated data pipelines? And so that's the type of question that our platform is ideally suited to handle. I think there were other parts to your question, but I think that was
I think that, so it could really be used for both. You can help design the data collector, if you will, the sensor or whatever it is, based on knowing the outputs you want. But if you have a sensor already and you want to, better understand the data, you can also use those simulators, twin it, and be able to create then synthetic data, knowing what that sensor can do.
Absolutely. So for instance, in terms of designing the sensor, and we've been public with Planet, right, for their Tanager system, their hyperspectral system used our platform, not only to assess their hyperspectral sensors, but then to hydrate their data pipelines ahead of launch so that they'd be ready. And in fact, part of that process is building data sets that they could use with their customers right before they launch. So their customers can start to look at what the likely data will look like and plan and build their own systems to interface with Planet. So that was an exciting program. A lot of what we do is with sensors that are already fielded, and a chunk of that is satellite, but everything from security cameras to X-ray systems, where there is an existing tool in the field. And which then raises the question, well, why don't you have the data? And then the reason that people come to us is because they're always dealing with rare events, edge cases, the changing. And you've said a number of times, the reality is that the world changes. And so if your performance is based on only things that you've previously seen, you're constantly out of date. And so synthetic data helps you to get ahead of that.
So with synthetic data, how can you tell if you look at, let's say, a current sensor does produce data, but you're looking for an edge case of things that have never been seen.
Yeah.
And until they're seen, you won't know if the synthetic data was correctly modeled. So how do you tell if what you're developing is correctly modeled, or is it just a matter of math that you get it down to a point where it may not be perfect, but it's within a very small, error window?
Oh man, these are great questions. You clearly came prepared. There's a lot of subtlety to this question. Okay, so let me start with even just unpacking what do we mean by correctly modeled? Because there's sort of physically correctly modeled. Did we model the physics correctly? Did we model the sensor correctly? Did we model the object of interest correctly? It turns out that's maybe 25% of the battle. Because to get to effective data, we also have to sort of model the rest of the world and have like diversity of scenes, of environments, of, if I'm imaging a field, great. Well, that field looks different based on what the soil looks like, what the moisture looks like, which crops and how tall, and all sorts of variation in terms of what I might see when I actually image that field. So if you want to build effective synthetic data sets, there is some amount of that diversity that is important to model. And I say some amount, and that's usually one of the important questions. It's like, which parts of the diversity are important and which ones aren't, right? What can we safely ignore? So first of all, that's, to talk about correctly modeling something, it's not a black and white answer. And part of what we try to do with our platform is not necessarily say, hey, it's exactly this, and like press that button, you're done, but give you tools to begin assessing whether or not you have the appropriate diversity model. Now, there's a couple of things that we do in order to achieve that. The first is a tool, and I don't want to get too tech jargony, but we use a tool called UMAP analysis. And essentially what we do there is we actually take the imagery that we're producing and we pass it through the first layers of a detection model. And essentially what we get out is this very long, what's called feature vectors. So we get like, we started with 1 million numbers in a picture, if you think about that. And when we pass it through the model, we get to like 200 some numbers. And then we start to, that's like more manageable. We can compare images more effectively. And we go from 200 and we actually use some clustering techniques and bring it down to 3. And now we can plot those 3 numbers for each image. Does that make sense?
Mm-hmm.
We can ask questions like, how close are these 2 images? So when you say, is it properly modeled? One of the things we can do is we can look at the distribution of a real data set. And we can look at the distribution of a synthetic data set. And we can say, or are the features in the synthetic data set overlapping with the features in the real data set? Now, there are times where you expect them to overlap exactly. And if they're off, that means that you're not modeling something correctly or you haven't captured the diversity. There are other times where maybe, there are effects in the synthetic data set that you don't have in the real data set and you want them to see as being represented outside of that cluster. So it does still take some human analysis to fully understand that. But what we do with the platform approach is we try to codify those steps and then kind of make it really quick to be able to do that and quickly visualize, hey, how do these data sets contrast?
So coming from military background, flying jets, a lot of scenario planning. So you're trying to plan from data sets that, humans can change, but it's within the realm of, decision makers, of someone that you don't. Does this apply to something like that? Or is this much more of a, you talk images a lot. Can it be applied to that? Scenarios like that.
Scenario planning, and I'd say just broadly pre-mission planning is one of the areas that we do see a lot of demand. It's a novel area for DoD, but if you think about a unit that's preparing for deployment, oftentimes they are deploying with AI tools these days, whether those are sitting on drones or otherwise. And so the ability to predict what is likely changing in the field and to make modifications ahead of time as part of your preparation is one of the things that we see demand for. Because the reality is otherwise you're essentially deploying with software that's 6 to 12 months out of date and may not reflect the realities of the field.
Have you seen use cases where it's also used real time as situation changes? You can then inject, okay, here's the now new normal. Where would, for example, scenarios or, based on the situation, it's changed. What does it look like now?
We see that need out there. I will say most of the world is still just trying to do basic object detection. That's very much what you're describing.
That's the demand case.
Yeah. That is the majority of the demand case. That being said, what you're describing, which is sort of, if I could paraphrase, the question that I pose myself and our team is, in the future, it's not going to be a person trying to improve an algorithm. It's going to be an algorithm trying to improve itself. And whereas right now we can produce an engineering workflow and it sort of makes sense that we'll have computer vision engineers that use that workflow to improve the algorithms. And that is the way the world works today. That's probably not the way a good chunk of the world's going to look in 5 years. Right. So how do we get ahead of this and make it really automated so that a tool, at the edge, whatever that tool is, can recognize that it's having trouble with detection and can form a meaningful request for either more data or a refinement of its algorithm and get that feedback either in real time or in some manageable time with no human in the loop. And that's where I think it's really exciting. It's where we're starting to integrate what are called agentic workflows into our framework. And so essentially you can think about like chatbots, right? Large language models. But when we the way that our platform works is really we can drive the synthetic data generation through graphs, and large language models can produce those graphs, which means that we're in a place very quickly where basically the English language request can be used to drive data generation. And then we just have API access all the way through the model training. And eventually we'll be able to close the loop as well. And so that's forward leaning. It's not where the market is today. And the tech it has some work to do to get there. But you can see it from here, if that makes sense. And so
absolutely. It's going to be interesting because it is rapidly changing.
So, and on that note, and I don't know if you are aware, but our actual company name, so we are doing business as name is Rendered.ai. Our actual company name is DADOES, DADOES, which stands for Do Androids Dream of Electric Sheep.
Love it.
And so from the beginning, we've sort of had in mind that eventually it was not human eyeballs that this data was intended for, but really automated, robot eyeballs. And that's been the vision from the beginning. So now we've been building, and I think we've got a platform that's demonstrating a lot of value as an engineering platform. But the next steps are even more exciting, where we get to automate that whole process.
Are you on the forefront of synthetic, creating synthetic models using, AI, synthetic AI, or are a lot of folks jumping in this quickly?
There's a lot of people in the synthetic data field. The vast majority of them are essentially repurposing video game engines to produce output, which is great. I think that there's a place for that. I think that we are the only ones that are thinking about this as a broader engineering challenge. And really the distinction is, are you trying to produce a synthetic data set, or are you trying to produce a performant computer vision model? Because if you're trying to produce a synthetic data set that sort of looks good, then you can kind of grab a video game engine and it's like, how quickly and cheaply can you produce the data set? once you say that your objective is actually to provide a performant algorithm, the types of engineering and the types of workflow that you need increase dramatically in complexity. And that's what we've been building for. And yeah, I think we're the leading experts in that.
Fantastic. So how about in the defense sector? What are the challenges you're seeing in, data generation and these AI models?
We do a fair amount with the defense sector. We can acknowledge now we're an Ecotel portfolio company. What are the challenges? The challenges are myriad. I mean, the defense sector is not a monolithic entity. We see some really exciting opportunities around programs like Maven at NGA. We also see a lot of need across the various combatant commands for things like preparing for deployments, like I highlighted. There's a lot of need in Air Force as we work towards autonomous tooling that needs to be updated regularly. So if you think about drones and that stack. So there's a need everywhere. What I think is most notable, if we kind of elevate it not from like the specific use cases to what's important broadly, I don't think anybody would argue that artificial intelligence is going to be a core part of DoD going forward. I think it already is and is only going to become more and more important. And I just want to repeat something I said before, which is like artificial intelligence is just software, but we write it in data. And if we can't get our hands around how we produce that data and stabilize and standardize the ways in which that's produced, we're never going to be able to stabilize and standardize the behavior of our AI systems. And so a lot of these, and where we see the need on the DoD side is there's a bunch of these specific places where that data is needed. But the meta level problem is that the entire DoD needs to be able to start standardizing the ability to produce this data and use it in a consistent way. Otherwise, the engineering will never be consistent.
That's going to be a challenge for the DoD to standardize around anything.
Yep. It's okay. It's okay. I mean, our business model is not predicated around everybody has to adopt a standard, but we do think, and what we do see is, we can be as standard. And for those people who do adopt that standard as an approach, as an engineering approach, there are huge advantages. I mean, it means you get all this reuse of simulation engines that have been integrated. You get things like 3D model and environment reuse. You have example workflows that have already been proven out. So you get tooling right on top of that for training that has already been proven out. So, the standardization comes with some significant time and cost benefits.
Are there misconceptions, you think, in how synthetic data can be used in, we'll say defense applications, but really any type of applications that we're talking about?
I think the biggest misconception is that people initially think about synthetic data as if it's just real data. They're just like, give me, like if I make a real data buy, then I'm like, okay, here's my bucket of real data. And typically when we engineer, what we do is we take that real data bucket, we separate it into training and test, but they're from the same bucket. And so, inevitably you can get good performance because they're from the same, what's called the same domain. With synthetic data, we're sort of producing data that is necessarily from a different domain. You start, right? It's produced from a different bucket. And so if you use it single shot, you heard me say this, it almost never works. It never works. Like very rarely and only in very easy use cases does that work. And it's because you need to go through this engineering process to figure out which characteristics of that data are relevant and important as you approach not just synthetic data, but effective synthetic data. And that's the biggest gap we see is you have some people that are like, oh, synthetic data doesn't work. And it's like, okay, hold on. How did you use it? Oh, you just grabbed a bucket of synthetic data and tried some random training paradigm and that didn't work. Okay. That's not, it's like saying the internet doesn't work. And it's like, did you plug it in? Like you need a modem. So similarly here, like there are engineering steps you have to take in order for it to be effective. And increasingly, that's what we really try to educate people on is it's not, can synthetic data be effective? It definitely can. The question is, what steps are required to make it effective and how do we accelerate those steps?
Very good. Do you see any, with synthetic data, any ethical concerns as you're moving forward? We've seen some concerns with that in the field, but have you run into any of them, or do you foresee any problems with that?
I mean, the first things we see are I'd say ethical benefits. I mean, we've worked on programs, for instance, to be able to create data with people that have different skin tones that allow for medical companies to better detect things like rashes and eczema. And so, I think is a positive to be able to overcome kind of inherent data biases that can be present in our data. The broader sort of ethical concerns on synthetic data, full stop, are the ethical considerations around artificial intelligence. I mean, at the end of the day, this is a tool set that does help to push detection and artificial intelligence forward. And I think I have a philosophy that's sort of similar to most in the technology industry, which is, we want to be thoughtful about this. We want to be good corporate citizens. These capabilities will be coming forward. If you look at US DoD, we want our team to have the best tools as early as possible, and that's a part of our mission. But from there, it's not in our hands to control how everybody uses AI. We can't pretend that it is.
Do you see a future where this becomes a problem? I think, like, is this, I'll use Elon Musk, for example, but, there's other folks. He's more, I'd say, vocal about his concerns with OpenAI, from someone who this is their field. Do you have concerns that ethically this has a real probability of getting out of control?
Any technology can get out of control and be used inappropriately. And we see that all the time with technologies that have been around for hundreds of years. And so, can it? Yeah, sure. There's maybe two things that I'd call out on this question. One, I actually sit on the advisory board for the electrical engineering department at Duke. And we have these conversations like, how do we make sure our students as they come out are well-rounded and are prepared to make ethical decisions? And I think as engineers, we are responsible for producing humans that do the engineering that have broader backgrounds than just the technical disciplines in which we're naturally trained. So that's not really an answer to your question, but it's part of the answer is the community that produces these and doing the work to make sure that we're building, a stronger and more thoughtful community. The other thought that I'd have is there's questions of if somebody uses a tool inappropriately, and then there's a question of if the tool behaves inappropriately or unexpected. I think of synthetic data as an incredibly powerful mechanism for correcting the latter. Because once we can get a handle on what the inputs are and have knowns about what the inputs are to our algorithm training, we can actually close the loop. We can meaningfully close the loop. If we see it doing things that we don't expect, we can actually get control over the data that defines its behavior, and we can modify it.
That's good. Definitely be interesting for sure. Yeah. As you've got a transition just a little bit, as you've, now been in startups and the education side, what advice would you give to entrepreneurs or innovators that, want to get in the defense sector or into AI as they move forward? Like, what have you learned, some of your top 3 highlights of, okay, just keep this in mind as you move forward?
I think I'll give you top 1. I'll narrow it down to this. So I've now advised over 100 companies over the last 6 or 7 years. And the number one thing that I actually see, and I try to work with entrepreneurs, early entrepreneurs, first-time entrepreneurs on, is are you familiar with the hero's journey? Are you kind of aware of that as a mechanism for storytelling? It doesn't. Okay, not the specific.
Not in that term, but maybe.
Many entrepreneurs, when they come out of grad school and they're going to start a company, are in their own minds the hero in this epic story. They're starting something. They're out and we have a feedback loop culturally that tells them that too. Oh, you're the CEO and you're grinding through the hard stuff and you're going to make it, whatever. We have that echo chamber. I think you're familiar with it. And one of the things, I think that's actually, it can be very damaging for our early entrepreneurs. And especially for technical entrepreneurs, it's not their natural way of wanting to think about themselves. It's uncomfortable, it feels weird, and it drives them to do strange things. And when you say, hey, why don't you take a step back? Tell you what, let's make our customers our heroes. And let's be the mentors in the story. And let's think about them as the ones that are on this really hard journey. And let's think about, if it's DoD, it can be anybody. Let's think compassionately about not just the DoD as a customer, but the individuals in the DoD that need to use this technology and the challenges that they're facing, and think about how we, both through the technology and tools that we provide, but also through our own engagement and our human engagement with them, how we support them in that journey. That is often the most enlightening thing I can say in, in a short conversation with an entrepreneur, because it can change their mindset. And it's like, once they start thinking about themselves in a position of supporting their customer, a lot of other things go better for them.
Right. I think that's great guidance. It can be a trap early on. You see it.
We've seen it. Yeah, we've all seen it. And shoot, I think I fell into it. Right.
Yeah.
So like I said, scar tissue that other people don't have to have.
Well, I mean, and to your point of moving technology, your first company, like we needed a growth team. Like to be able to step away from your baby, that had to be a very challenging decision, but it takes a lot of emotional intelligence to see that, okay, maybe it's time.
Yeah, it was time. It was time.
Awesome. Well, we'll wrap up, but I guess I would ask you, what's next for Rendered.ai? Any developments or big plans that you can share?
Well, I mean, you're going to see a lot of interesting features being pushed out here, but a big thrust for us is automating this complete workflow. So you can think about the work that we've done so far has been things like integrating simulation tools, integrating content to be able to produce synthetic data sets. And actually, we've just recently released some tools for model training on the platform. The next major arc for us is automating all of those, so that instead of having to use all these tools, you'll just be able to come in and say, I want data that looks like X, and not just get the data, but then get trained models and be able to start closing the feedback loop automatically.
It's going to be great. Yeah, it's going to change. I mean, data drives everything, and it will be interesting to see how quickly we adopt and how it's going to change just some basic things we do in life to the advanced. It's going to be fascinating.
I agree.
Well, thank you very much. I do appreciate your time. I could talk. It's just fascinating. You're obviously one of the leaders in this space, and man, it's been great. But if folks want to follow you or just, your company, how best would they do that?
We're active on LinkedIn. So that's probably the best way to follow us, just at Rendered.ai. I'm also available, and feel free to reach out to me there. I'm not quite as active as the company, but I still try to post updates. I can remember to.
Well, that's great. Well, thanks, Nathan. It's been super fun and really appreciate it. And let's keep in touch.
Great. Thanks so much.
All right. Thank you, Nathan. Bye.